All right, well, welcome everybody. Good morning and thank you for joining us for our Modern Stone Fruit Training Systems webinar. My name is Mike Basedow and I'm an Extension Tree Fruit Specialist with Cornell Extension's Eastern New York Commercial Horticulture Program. And we serve the 17 counties of Eastern New York up and down along the I-87 corridor. Today, we've already heard at this point, I'm also joined by my technician, Andy Gallimberti, who's helping me manage everything behind the scenes today. So a few housekeeping items before we get into the meat and potatoes of our meeting. We ask that you remain muted and that you keep your cameras off while our speakers are presenting, just so we can conserve our computer bandwidth. Certainly up here in the upper portions of upstate New York, our bandwidth can be limited sometimes, so we like to keep our cameras off for the most part. You can do that by looking at the lower portion of your screen. You'll be able to find the mute and unmute button, and then also the start and stop video. So again, we ask that you please keep your mics and your video off during the presentations. As questions do come up, you can find the chat box by hitting this chat icon near the bottom. That'll open up the chat box for you. So as we're going through the presentations, if a question pops in your head, feel free to type that into the chat box and we'll get those answered at the conclusion of each speaker's presentation. I also want to mention, you can just take a look at our overall agenda. So we'll have a few different speakers today. Also to point out, the last 20 minutes of today's meeting is going to be a bit more of an open Q&A session. So at that point, after we've heard from all our speakers today, you'll have an opportunity to unmute yourself. You can turn your camera on if you'd like, so you can continue asking them all questions either through the chat box, or you can do it face-to-face live as much as we can. So with that, if you do have any technological issues throughout the meeting, if you have poor audio quality, please let us know in the chat box as well. We'll try to take care of that as best as we can. I'll also note that there are no DEC credits for today's event. If you are still looking for DEC credits, we are still offering a couple others through some other meetings that are happening through the rest of the month. Keep an eye out on our newsletter for that. And then thanks again and enjoy today's presentations. So I'm going to go ahead, stop sharing my screen, and I'm going to invite Dr. Jim Schupp to share his.
Good morning.
And while he gets his presentation up, I'll just like to introduce Dr. Jim Schupp. He's a professor of pomology at Penn State University, located at the Fruit Research and Extension Center in Biglerville, Pennsylvania. His areas of expertise include tree fruit production, orchard management systems, crop load management, pruning, and training. And thank you for joining us, Jim. I can see your slides perfectly.
Great. Well, good morning, everybody. It's a pleasure to be with you here in a virtual type of a meeting. I'm going to go ahead and talk a little bit about generally introduce the concepts of peach production systems and talk about some of the previous work that's led us to where I'm currently doing research right now. And I'll share a little bit of my current research with you towards the end of the talk. And so the rest of the talk will be kind of explaining how I got to that point. So if we look at what an ideal peach system might deliver, it should be a productive block. It should be pedestrian, peach being a fairly labor-intensive crop. You need, to whatever extent possible, keep it short. The fruit quality should be excellent. It needs to be precocious and come into production early. And above all, it should be teachable. So if we look at more specifically production system goals, we're looking for economical production of highly marketable yields. And we also want that system to be compatible with automation and mechanization, with a goal towards, above all, labor efficiency with this crop. Start with the first trial that I conducted on peach systems here in Pennsylvania with my colleague, Dr. Tara Bacher. We conducted a trial with With yellow freestone peaches, we had perpendicular V trees at 484 trees per acre. That's a two scaffold system. We had quad V trees at 346 trees per acre, hex V trees at 242 trees per acre. And we compared that to the conventional low-headed open center or open vase type system that predominates in this region at 173 trees per acre. I'm not going to show you all the data because I've presented that at IFTA and various fruit schools and Mid-Atlantic Conference and so on over the years, but I am going to summarize what we found. And in short, the medium density systems, the quad V and the hex V, were the best. And when I say they were the best, they had higher marketable yield per acre. They had redder fruit color. They produced more economic value and more efficiently. When we compared them with the open center system, the open center system produced a slight savings on labor because the trees were truly pedestrian. However, it took 2 years longer, excuse me, for the open center trees to fill their space, being at only 173 trees per acre. And although they produced larger fruit sizes per tree, there was less fruit on this system, and therefore also less large fruit on a per acre basis. So the medium density systems were very good. Why did the medium density V systems perform better? And the answer comes down to they had more linear bearing surface per acre. And we did some very detailed measurements for 2 years where we went in and counted and measured the numbers of fruiting laterals per unit of land. And we came to the conclusion that we got just as good a result or just as good an answer by just taking the designated number of scaffolds per tree and multiplying by the number of trees per acre. And that's a lot easier than measuring all the shoots. It basically boiled down to, with the quad V, we had twice as many trees per acre as we did with the open center trees, but we had 60% more bearing surface. And so, you know, in a typical apple type of a systems trial, we would expect the highest density trees to be the most productive. And the perpendicular V trees had the highest tree numbers per acre, and it's 300% that of the open center trees. But the amount of increase in bearing surface per acre was only about 12%. And so you planted a lot more trees, but you didn't really increase the amount of bearing surface per acre as much. With these taller, more open trees, we got better light interception. We captured more of the light per acre. The training of these trees was compatible with the natural growth habit of peach. And therefore we got less aggressive, less of that, I guess we would call retaliatory growth that we would get with a heavily benched open base type system. And we had better light distribution within the canopy, and so they don't shade themselves. I wanted to give a nod to some of my colleagues at the University of California, Davis, Kevin Day, as well as Scott Johnson, and the other name escapes me at the moment. Oh, Ted DeYoung. They helped me a lot with my early understanding of the V canopies, the Kearney V, and so on. And Kevin always talked about having regimented canopies, having the scaffolds in a nice row. And that's what the V canopy delivers. It delivers a two-dimensional canopy, which, whether it's a camera system on a robotic system or whether it's a human being, you have increased visibility and easier access to the fruit. You have a simpler tree architecture, and that makes benefits in terms of not only manual labor efficiency, but it also increases the efficacy of mechanization and future automation. So we were able, with these V-type systems, to make very good use of a platform, and we use that for thinning, for mating disruption, for summer pruning, and for harvest. And depending on the task, it increased our our efficiency, our labor efficiency, somewhere between 15% and 50%, depending on the task at hand. And so to some extent, we were able to overcome some of the higher costs from having taller trees by employing a platform. We also were able to use the Darwin mechanical string thinner to good effect for blossom thinning. And with the V-type systems, we were able to go faster when we did our thinning than with the over the top with the open vase. So you have to slow down, and the operator has to make very vigorous use of the joystick in order to have that spindle turning in close proximity to the blossoms. And so you have to slow down with open center type trees. We also get a better job with the efficacy. And if we look at the White Lady V system there in the center, you can see that we had very good flower removal with the string thinner, better than the open center trees. The two open center tree plots are shown, and these are commercial orchards, by the way, shown below the White Lady. And when we prune those trees to remove branches on the inside, that's called a partial fan. And you notice that compared to standard pruning, we got even more increase. And pruning them to a strict fan wasn't necessarily better than just to a partial fan, but we were able to get a better effect with the mechanical blossom thinner simply by improving the narrowness of the tree canopy. Detail pruning also gave some benefit in terms of thinning efficacy. So we know that we noted that the intermediate distances with the quad V and the hex V were the best in that previous trial, and it led us to the question: is it the number of scaffolds, or is it the spacing? And so we decided in this trial to hold all of the trees to a quad V. So we conducted a trial with all of the trees were in a quad V, and we altered the in-row spacing from 5 to 7.5 to 10 feet between trees. The between row spacing was held standard at 16 feet, and that gave us trees per acre ranging between 545 trees per acre at 5 feet down to 272 trees per acre at 10 feet. This trial was conducted with Coral Star, and we had an opportunity to introduce rootstock as another variable to test. In 2012, when I was setting this trial up and ordering trees, the most exciting rootstocks that were available to me at that time were the Empyrean, and then KV 10123, which was one of Ralph Scores' selections out of Kearneysville, West Virginia. We compared that to Bailey as our go-to standard. We also used Krimsk 86, which is a rootstock that's increasingly becoming available simply, I think, because it's an excellent almond rootstock, and therefore a lot of West Coast nurseries are producing both almond and peach trees on Krimsk 86. And we also wanted to test Guardian. And again, Guardian was developed for peach tree short life in the Southeast, and increasingly we're seeing trees made available in the mid-Atlantic area, at least on Guardian's rootstock. So we included that in the trial as well. So these were all quad V, and in order to have more uniformity in terms of the scaffold training, we introduced a V-type trellis and used 8-gauge plastic wire in this case to trellis the trees. To summarize the results, Bailey was the best rootstock in terms of its precocity, productivity, and its moderate vigor. KV 10123 was also productive semi-dwarf tree. Guardian was a productive standard size tree, and Krimsk 86 was the biggest trees in the trial and would be an excellent rootstock where you need that additional amount of vigor. Pinto, on the other hand, was a semi-dwarf tree, but it was also the least productive rootstock. And out of these would be the one that would not be recommended for trial. All the rootstocks except 10123 responded very similarly to changes in spacing. KV 10123 was interesting in that it was among the largest trees at the wide spacing, but at the closer spacings, it was among the smaller trees. And so should KV 10123 become an interesting option for commercial producers in the future, that's something that we should look at a little more depth. The in-row spacing summary produced some very interesting results as well. When we place the trees at closer spacings, 5 or 7.5 feet versus the wider spacing of 10 feet, we got, over the course of the study, we got 50% or 25% more yield on those closer spacings on trees that were 45% or 31% smaller, respectively, than at the widest spacing. So we have a lot of tree size control being exerted by the in-row spacing, and it seems to be fairly proportional to the in-row spacing. Fruit size was 6% smaller over the course of the study at 5-foot spacing than at 10 feet. And although the peak sizes were still very marketable, that's something to be aware of, that as we go to those very close spacings, the fruit size did drop off. And you know, I guess one way that would have a practical outcome would be if you have a small fruited cultivar, you know, Red Haven season or something, you might use 7.5-foot spacing instead of a 5-foot spacing, because the fruit was only 3% smaller at that size. Mineral nutrition we followed for the final 3 years of the study, and the differences were very small among these different treatments compared to the changes that we saw in terms of tree vigor and yield. Over the course of the study, the increased yield that we were getting and the increased competition at closer spacing did, the very last year, affect nitrogen and leaf nitrogen levels reached the lower threshold for action at the highest density, but only after 6 seasons of production. Nevertheless, with this higher density type of a planting, annual leaf analysis is strongly advised, and be aware that because you are producing a lot of fruit on high tree numbers, that mineral nutrient analysis needs to be closely monitored. So perpendicular V systems, particularly the moderate density ones, allowed us to split the canopy into narrow tree walls. It increased our yield and fruit color. It would facilitate mechanization. However, it creates a couple of challenges that are difficult. One of which is that we have a labor-intensive crop, and at the very beginning, I told you we wanted a short tree. And with these very tall systems, you know, 10, 12-foot tall tree, it's a labor-intensive crop, and that means that you have to go up there to perform those tasks. Secondly, renewal pruning can be a challenge. Peach is very intolerant of low light conditions and a little less likely to produce renewal branches, as is, for instance, apples. And so that's something that has to be very closely followed, and very great attention has to be paid to getting good renewal growth, particularly in the lower half of the canopy. Perhaps we'll take a moment here and talk a little bit about pruning these tall V-type systems. Have perpendicular V trees here, and showing how they looked after a season of production, and then after pruning. And the steps are basically to reduce and thin out secondary limbs. You want as little secondary growth as possible. In a perfect system, you would have fruiting laterals coming directly off of the scaffold, and in some cases you do. In other cases, it's at least here in the East, it's necessary to do renewal as shown here, where you prune back to the first strong fruiting lateral in order to leave enough fruiting production in the bottom of the tree. And so when you do that, you cut to a fruiting lateral, or at least to a strong bud that has possibility of producing a good fruiting lateral. And you need to make sure that you're pruning hard enough in the top of the tree and on the inside of the tree so that you're maintaining a good light environment, because once you shade out that lower canopy with peach, you're done. So the final step with pruning for peach pruning is to prune for a peach crop load goal. And this refers to how many of those fruiting laterals you need to leave. And so the V-type systems lend themselves very well to this kind of calculation. So if you set a goal for yourself that you want to produce 600 bushel per acre of large fruit, which here in southern Pennsylvania is a very doable goal with a quad V, that means you need 60,000 peaches per acre. And we have 346 trees per acre. So that means that in order to get our goal, we need to have 173 peaches per tree. We have 4 scaffolds on each of those trees. And so that means we need about 43 peaches per scaffold. If we're gonna grow 2 peaches on each of the fruiting laterals on average, then we need about 22 laterals. And so the ballpark for reaching our peach load goal would be to prune those trees so that they have about 22 fruiting laterals per scaffold. And what I will do is I'll prune out some trees with very closely counted numbers of fruiting laterals per scaffold, and I'll show that to my pruning crew, and I'll say, see that? Make the rest of them look like that. And it gives you a way also that you can come back and spot check and see if the pruning crew is taking too many or leaving too many, and it gives you a very good way of getting yourself in the right ballpark. You still have to thin, but if you thin everything out well, you should be in great shape with your crop load. So let's take a moment and just kind of summarize where we've been, because this kind of sets the thing for what I'm going to talk about next. Our peach productivity in the eastern United States is very low under the low-headed vase system, and we need to do something about that. We can't just keep doing what we've been doing for over 150 years. We know that the taller quad V systems double our yield per acre, and we know that narrow shape is very compatible with mechanization, and but it's a labor-intensive crop, and growers have made it very clear to me that they want their orchard kept pedestrian. So I've continued to try and figure out how we might do that. So our prior research, you will recall, showed that when we went to the closer spacings with the semi-dwarf trees, that we reduced the tree size by 30 to 45%, even with seedling rootstocks. And so we decided to take that a step further. And so in this case, we planted trees of Starfire. It's an early season yellow freestone peach. We used level for our rootstock, and we put them in 10 tree plots with between tree spacings of 2, 3, 4, or 5 feet. And we set the rows 12 feet between rows, and we added trickle irrigation. One of the things that you must do with these intensive and even the medium density systems is you must always remember that as you increase the competition in the orchard, that you're trying to produce a crop that's 89% water, and you need to make sure that the water is adequately available. So these very close spacings gave us a range from 726 trees per acre up to 1,815. And we used a T-trellis, a simple T-trellis with either plastic coated high tensile steel or egg liner monofilament. It's a hard plastic monofilament string to create the 2-wire trellis with a single wire on each side at 6 feet height. And we used mechanical hedging and mechanical blossom thinning to try and reduce our labor costs and expenses. And we used one scaffold per tree was removed after harvest this past year, And the idea is to try and promote renewal of the entire scaffold down low on half of the tree and leave the other half. Well, we left one set of plots with both scaffolds intact. We'll see this in a second. So the goal here was to evaluate the intensive mechanized pedestrian peach system at very high densities with 2, 3, or 5 feet, 2, 3, 4, or 5 feet between trees. We're also trying to determine the feasibility of whether we can use scaffold renewal to maintain the pedestrian trees that we want and minimize labor costs. And furthermore, I think with these densities, we'll be able to identify the biological limits of intensive peach systems in the Mid-Atlantic. So we start with dormant pruning. And some of you who have heard me talk about my how nervous hedging makes me will know that this was a leap of faith for me. So, but we did use dormant pruning, and I would simply point out to you that with these very high tree densities and the reduced vigor that I've documented that we're seeing with these high densities, I think we can maybe pull this off a little more easily than we could with more vigorous trees at spacings that would be more productive or more inclined to grow. And so we used dormant mechanical hedging and then came in and did touch-up manual pruning, cleaning up the stubs in the top of the canopy and selecting our fruiting laterals to get the appropriate number, and as well as removing any laterals that are on the inside of the V. Mechanized blossom thinning was also used. We used the Darwin string thinner. And here you can see from left to right one of the scaffolds before, during, and after blossom thinning. We try to, I guess I would call that maybe pre-thinning. We come back and do touch-up hand thinning. We also did summer hedging to increase the light in the canopy later in the season. And then at the end of the season, we came in and did scaffold renewal, where we removed entire scaffolds on one side, kind of on an alternate row middle type of a thing. And we removed them at about 30 inches of height. You can see how that looked after the season ended. Hand thinning time, and remember this would have been with 2 scaffolds per tree at this first year. It ranged from about 20 hours per acre down to about 10 or 11 hours per acre at the lowest tree density. So hand thinning time was reduced by the mechanical blossom thinning. We also documented full sun, the percentage of full sun in the upper and lower canopies. And you note that there were some subtle differences in the amount of light in the upper canopy with regards to tree density. However, all of them had adequate sunlight to function fully, and even in the bottom of the canopy, they were in good shape with the light levels. We picked our first crop in 2020, which was exciting. When we look at kind of a summary of how this orchard performed in 2020, over on the left is the tree density, or the number of trees per acre. And if we express tree size as 100% of the biggest trees, which were at 726 trees per acre, you can see that with each increase in tree density, we had a corresponding reduction in tree size. It is on the order of 20 or 10% at each interval. Yield followed a similar kind of a pattern. We had the highest yield per tree at the lowest density, and the lightest yield per tree at the highest density. However, that was more than compensated by the the number of trees per acre. And so yield in terms of bushels per acre was highest at the high density. And this is the very first year. So this would be the third season of growth and the first season of cropping. We had between 245 and 340 some bushels per acre, which is fine for year three. Fruit size is the one area that, again, we need to be cognizant of and concerned about. The largest fruits in this tree and these trees were at the lowest tree densities, and they were right around 2 3/4 inch peaches on average. But when we got to the very highest density, 1,815 trees per acre, we're at about a 2.5 inch peach. And so the amount of competition at that high density is very marked. Fruit color was just awesome. This is I often linger over this slide, just thinking about how things are going to be next August, hopefully. But when we look at percent blush, you can see that all of them were up around 56% of the surface covered with attractive red blush, up to 62%. And soluble solids ranged from 10% to about 12%, and with some differences, but I think all of them pretty acceptable at this point. So it's too early to really make any firm conclusions, but we can note that after our first year of production, that the trees at higher density are smaller than the trees at lower density, as we saw with the medium density study previously. That yield per tree declined with increasing tree density. However, yield per acre increased with increasing tree density. Fruit size is declining with increased density, and this is one of the areas that I'm interested in seeing if we can manage this a little bit better. Perhaps tweaking our irrigation or fertilizer practices, and to see, I think though at the end we're going to basically be able to say how many trees per acre is too many trees per acre, and I think that fruit size may be the limiting factor for this tree density question. So pedestrian trees are wanted, and we don't want big trees. And so I think that I want to just mention the controller size controlling rootstocks have been studied in the NC 140. I believe Terence will talk about these in more detail, but I want to point out that the controller series are peach crosses. It's peach by peach. They're producing a semi-dwarf type of a tree that gives us enough vigor that we can produce good fruiting laterals, but small enough that I think it'll help us a lot with keeping the tree height down. They're yield efficient and precocious. And in the 2009 NC 140 trial, I note that controller 7 and controller 8 had no mortality in Pennsylvania, New York, and Massachusetts, the three closest states for today's purposes. And we're studying those three, controller 6, controller 7, and controller 8 in the 2017 NC 140 trial with Cresthaven. And we're comparing that with a number of other interesting rootstocks. I'm going to skip through this quickly just to point out that here's a picture of controller 7. And again, it's about a 3/4 size tree and seems to be a very productive, hardy tree in our climate. And I'm going to skip this one too, just to take a look at the controller 6 trees here to the left, and very productive, exciting new rootstocks. So I'll stop by acknowledging the State Horticultural Association of Pennsylvania and the Pennsylvania Peach and Nectarine Program, two grower organizations that have been very instrumental in funding our research, and I thank them for that. And I'm going to close here. I'm going to leave a slide up for just a second that has a website if you're interested in taking a look at quad V training. This video is quite good, and it talks about the training and pruning of the quad V trees. So, Mike, I'm going to stop there.
All right, great. Thank you, Jim. We do have time for a question or two, so if people want to type them into the chat box, or even if someone wants to take themselves off mute and ask Jim a question, we do have 3 minutes before the next talk is scheduled to begin, so by all means. Thought I might have heard someone on mute, but I'm not sure. Jim, I do have a question for you.
Yep.
The timing on, oh, is there someone else popping in?
I can ask. Okay, I wanted to ask something.
Sure.
In the system where you take off one of the two main limbs, do you plan to do it every 1 year, 2 years, 3 years, or how often?
Yeah, that's an excellent question, and I'm going to answer you by saying I'm going to feel my way through that cautiously as we go. I wanted to start that right off the bat after we got the trees into production. So the third year of growth was the first year of crop, and right after that we removed one of the scaffolds. I believe it may take 2 years to, in my climate, to replace that canopy. And so I think what I'm going to do is watch and see when that canopy has refilled its space before I remove the other one. So my goal here is always to have as much crop as I can, and if they surprise me and refill that canopy in a single season, I'll be happy to do it annually. But I believe it's going to be probably a 2-year basis. But the honest answer is I don't know.
Actually, you can even increase the distance between cutting by applying growth retardants, especially coal tar is doing a very good job. If you can do it, I don't know, in the US, but
yeah, unfortunately,
in Israel, yeah.
Yeah, unfortunately, yeah, coal tar is not registered for use in the United States. Otherwise, that would be a very interesting addition to this trial. Thank you.
Yeah.
All right, I see Tom Beckman has his raised hand. We can fit in one more question. Tom, go ahead.
Well, actually, I have two. We'll see if we can do this quick. One, have you tried using a single axis, something akin to a slender spindle or a tall spindle? And two, have you considered using any of the few available spur type peaches for these trials?
The answer to both of those is no. And I have worked with some of the upright and pillar peaches that came out of the USDA Kearneysville, Ralph Scores's program. And we find that unfortunately the number of those is kind of limited. I believe that Steve Miller did some pretty good work with the pillars and the uprights, but I have not worked with those as much. I'm trying to remember, the second question was the
Spur types.
Yeah, with the spur types, and I have not worked with the spur types either. The experience I have with the spur types has been with spur type Red Haven, and because of the very short internodes, you end up with a very compact. However, it's also a very dense canopy, and so you compact and create shading in a smaller space, basically with the spur types that I'm familiar with. So we have worked with standard growth habit peach trees for the most part.
Well, some of the newer ones I think would be a little more amenable to this. Things like Sherprints out of the Byron program, Gloria out of Rutgers, and Wash It to Gold out of the LSU program have more normal looking growth as compared to what you're referring to with the compact Red Haven.
Great, and I'd be really interested in corresponding with you, perhaps in private on that. That sounds really interesting.
Okay, fair enough. Thank you.
All right, great. Thank you, Jim. We do have one more question. And then after this, we'll move on to our next talk. But Magnolia did ask, is it possible to visit these trials? Are you taking visitors in Biglerville, Jim?
We hope so. I shot a bunch of video last year, and thought I had somebody lined up to be my producer, because I am not a video producer, but that I'm still waiting to see. We're also very hopeful that very soon here we'll be able to host a grower field day. We used to do it every other year, and we haven't done it since 2018. So I'm very hopeful that in the very near future that we will be able to host this. I will also mention that we've established a grower on-farm trial with 10 different growers across the state of Pennsylvania with the controller series of rootstocks. And so we have rootstocks all the way from Erie County, all the way over to the Wilkes-Barre-Scranton area, and all across the southern tier of counties as well. And so we'll hopefully be having a series of grower workshops to take a look at some of the controller rootstocks in a commercial setting.
All right, that's great to hear, Jim. Thanks so much. And are you going to be able to join us again for the Q&A session?
I'm looking forward to the other speakers, and I'll hang in there.
All right, thanks, Jim. All right, with that, I'd like to introduce our next speaker. We're going to switch gears and talk about cherries. So why don't we have Greg sharing his screen now. And while he gets that up, I'll give Dr. Lang an introduction. Greg Lang was the stone fruit research program leader at Washington State University in the 90s and has since been in a similar role at Michigan State since 2000. His work is focused on stone fruit rootstocks, training systems, and developmental physiology. So Greg, whenever you're ready, take it away.
Thank you, Mike. I appreciate the invitation to be a part of this workshop. It's great to be on the program with Jim and Terence. Great to see people like Tom Beckman and Amna Nerez all the way from Israel tuning in. I look forward to the discussion at the end. So Mike asked me to talk about sweet cherry at the very end. I'll talk a little bit about peach, so Tom, hang in there. But I'll start out with sweet cherry, and I think what I want to show you is the evolution of sweet cherry production systems from these giant old trees that this picture was taken probably in the early part of the last century in Italy to the modern very small orchards, very structured orchards that we're rapidly moving into. I think the reason that Mike, or one of the reasons Mike asked me to speak was we had just come out with this book in December of last year. It pretty much tells you everything, almost everything I hope that you need to know about growing cherries. And so it's readily available. It's at a pretty reasonable price. And we can put this, this location on the internet for how to get it if you wish. You can also just find it on Amazon. But it will cover a lot of the stuff that I talk about in this talk in terms of way we prune, why we prune, how we prune, timing of pruning, etc., to achieve various training systems. So I'd like to start by talking about the challenges for precision cherry management, because first of all, we're dealing with that large tree, the natural growth habit that the tree has evolved over centuries for survival. And when we look at the other tree fruits, we can look at peaches, plums, and apricots. And if you leave those trees alone in nature, they may get to be about 25 feet tall. Apples will get up to be about 40 feet tall, and pears will get to be 65 feet tall. But sweet cherries really take the cake. The sweet cherry in nature will get to be 135 feet tall if left to its own devices, because it's a tree that evolved to compete and survive successfully in a forest. It's a true forest tree, not an understory tree or an edge of forest tree. So we look at that natural cherry growth habit, because the better we can understand how cherries grow, the better we can then try to manipulate them most effectively and efficiently for a labor efficient, high quality orchard. That natural growth habit is such that with a seedling, growing in the first year, it's the top priority of that seedling is to simply grow a vertical leader. Start to grow from the soil towards the light in the forest. And so there are two key concepts that we talk about here. Apical dominance, in which the terminal bud inhibits the growth of lower buds behind it so that all the energy goes into extending that terminal bud, and also acrotonic vigor. As the tree ages, the vigor remains strongest in the top of the tree because it's always needing to compete with other trees in the forest for light. So in the second year, of course, the primary goal is to extend that vertical leader, but also start to initiate upright lateral growth, such as these shoots here, just below that terminal leader. And that's so if some big crow comes and lands on the leader and breaks it off, one of these laterals that start growing just below the terminal and very vigorously and upright, they can then quickly take over and replace that terminal and try to keep that tree in the survival mode. The lower secondary lateral shoots, as you see here, grow much less vigorously. They're weaker and they grow much more horizontally. This allows the trees to not put a lot of energy into those branches, but they can capture light that the top of the tree misses, and they can start to shade their neighboring forest competitors. So all different rationales for growth that allow the tree to compete in a forest. And finally, in year 3, we get a reiteration of those exact same growth habits. But an interesting thing to look at now as we're getting into year 3 is how the vigor in the tree is being diffused as the number of branches increases. So if we look at this first year leader, let's say it grew 5 feet in the first year. The second year, we see the leader extension may have only been about 3 feet, and the 2 side lateral most vigorous branches also probably grew maybe around 3 feet. We get into the third year and that leader maybe extends only 2 feet. So you can see overall, the vigor of the tree is increasing and capturing more and more light, but each individual branch is becoming less vigorous. And so this is a technique that we can use to try to manage the trees in an orchard situation. Here's a cherry that's about 35 years old. You can see it has multiple leaders. There's about 4 or 5 or 6 leaders here that have diffused the vigor over those 35 years. But what's really striking is even after 35 years, you can see all the acrotonic vigor in the top of this tree. The vigor in the top, the new shoots that grew last year, range from 3 to 5 feet, and there's probably 3 dozen of them or more. So clearly a sweet cherry tree is hardwired to grow vertically, as you see all that acrotonic growth in the top, and to grow vigorously, essentially forever, because that's how the tree can continue to compete and survive in the forest. Now in the 1990s, dwarfing rootstocks were developed and came into the picture for sweet cherry production, but early grower trials found that they tended to result in small fruit size, and there was a big question: do dwarfing rootstocks inherently not only dwarf the tree, but dwarf the rootstocks? But dwarf the fruit as well. So a graduate student of mine at the time in the late 90s, Matt Whiting, who's now a professor at Washington State University, did some studies looking at photosynthesis and leaf area. And it was leaf area that we found out is the main limitation to fruit size on dwarfing cherry rootstocks. Here we can look at the leaf area per fruit. So starting with about 1 or 2 leaves per fruit, and then increasing that leaf area, which we measure and quantify in terms of square centimeters of leaf area, and then looking at how that affects fruit size or fruit mass, as well as fruit soluble solids or fruit sugar. And we see that as you increase the leaf area, you get very large increases in fruit size and soluble solids up to a certain point. And after that, the increases are much less pronounced. So we've concluded that you can optimize your fruit size and sugar at around 210 to 250 square centimeters of leaf area. That translates to about 2 or 3 shoot leaves per fruit, or about 4 to 8 spur leaves per fruit. So now we've got a quantitative handle to start to figure out the carrying capacity of a tree, whether it's on a dwarfing rootstock or on a vigorous rootstock. So let's talk a little bit more about those leaves, spur leaves and shoot leaves. When a shoot first grows, there is one leaf at every node, and these tend to be relatively large leaves. The size of the leaves are dictated mostly by how much nitrogen is being taken up during the growing season. So in the first year, we develop shoot leaves. When that shoot matures, then the second year, what grew last year now has a little rosette of leaves, anywhere from 5 to 8 leaves at each node, and these are spur leaves. There's also a little bit of basal non-spur fruit at the base of that shoot. There are no leaf buds that grow here. There are only a few fruit buds that form. These spur leaves, the size of them is driven primarily not by the nitrogen taken up during the growing season, but by what was stored away in the nitrogen reserves in the tree from the previous year. And then when that section of wood becomes 3 years old, we now get not only the spur leaves at each node, but spur fruit. There may be 1 to 8 or 9 flower buds, each of which contain 1 to 4 flowers. So here we see the bulk of the cropping occurs in 3-year-old wood and older on these spurs that need at least 3 years to mature and can be maintained for many years beyond that. So focusing on this section of the fruit, this fruiting section, let's say it's 2 feet long, that would tend to be about 20 spurs in normal production, about 1.2 inches per spur. And so those 20 spurs with 5 leaves on average per spur and an average spur leaf size of 60 square centimeters means in this little section, we've got 60,000 square centimeters of leaf area in order to support fruit. Now, if the leaf area to grow a target fruit, let's say an 11-gram fruit, is 230 square centimeters, as Matt found in his work, and this has been confirmed by other scientists since then. We divide that into the 6,000 square centimeters, and we find that a target crop load would be about 26 fruit on this little fruiting section, or 13 fruit per foot of spur-bearing shoot growth. Now, if we have additional leaves, like those non-spur leaves or the new shoot leaves that can also feed those fruit, we can carry more fruit than that. Or if we can make those leaves larger, we can carry more fruit than that. So the question then was, how do we start to get a handle on quantifying the leaf area and the crop load, and how can we balance that? Because we typically haven't had much in the way of thinning chemicals for cherries, and we've done very little in the way of hand thinning. So back about 20 years ago, I turned to the grape production, looking at spur pruning on vertical shoot position grapevine training. Because with this type of training, we can, through our pruning, dictate the number of spurs that we leave on a cordon in a grapevine. We can then dictate the number of buds that we leave on each of those spurs on the grapevine. And we know that 2 fruit clusters will grow on every shoot that emerges from a bud on the grapevine. So simply by pruning a grapevine, you can achieve probably 80% of your crop load management and defining the leaf area to support that simply through your pruning. So we gain a relative precision in our crop load and leaf area management that can help us target our yields and target our fruit quality. So the next step was to grow a cherry in this way that we could simplify the fruiting units. We wanted to be able to quantify our leaf area better, our crop load better, and balance it. We also wanted to manage our vigor by diffusion of that vigor. So here we can imagine that fundamental fruiting unit of a cherry with the new shoots, the non-spur leaves, and the fruiting spur section placed on a tree. If we now think back to what we had just worked through in that fruiting spur section of 13 fruit per foot to get our target fruit quality, and if we assume that a single one of these fruiting units could be grown to 7 feet tall, we would need to produce 91 fruit in that offshoot, what we call an upright fruiting offshoot. Or the name of the system then became the upright fruiting offshoots, or UFO system. Those offshoots are spaced 8 inches apart. So we have 12 offshoots on this tree that is spaced 8 feet apart. And the rows are spaced, whoops, much more closely, about 8.5 feet, much more like a grape. So that we see in this type of training system with this tree spacing, we'd have 640 trees per acre, and that would give us a projected yield potential of about 7.5 tons per acre. So one of the nice things about this upright growth is A, that's what a cherry wants to do in the first place. It simply wants to grow vertically. And B, it puts out leaves in an arrangement pattern called the Fibonacci arrangement. Every 137 degrees, a new leaf comes out, so that those leaves that newly emerge don't shade the previous leaves that have grown, but capture sunlight. So it's an evolutionary, efficient way of capturing sunlight. This arrangement of leaves we can see growing from the side view here or the top view looking down optimizes light interception by the leaves and minimizes the shading of leaves below it. So this Fibonacci arrangement also occurs in the formation of new shoots. Each shoot follows the same pattern for light interception because each shoot arises from what was a bud in the axil of a leaf. But as the tree matures from a 2-dimensional to a 3-dimensional canopy, we see that shade begins increasing because of that 3-dimensional canopy. So both of these pictures are looking from the top down onto the tree, or basically looking the same way that a beam of light would be coming in to the canopy of the tree. As the canopy complexity increases, shade is increasing, and that's what requires us to prune to minimize. That's what leads to training systems. But the other thing to think about here is that fundamental fruiting unit. The part that's growing new shoots are in the full sun. The part that has where we start to transition from non-fruiting spurs to fruiting spurs, we're getting more diffuse light. And the part where we have a lot of fruiting spurs would tend to be where we have the most shade. So this is the habit that we're trying to manipulate to optimize fruit production. Not sure why I'm not able to advance. There we go. So the NC 140 rootstock group of scientists decided back in 2009 to put together a sweet cherry training systems by rootstock trial that starts to look at these types of questions. We took the fundamental fruiting unit of a cherry tree. We then looked at using that fruiting unit on 3 different vigor rootstocks, Gisela 3 being dwarfing, Gisela 5 being semi-dwarfing, and Gisela 6 being semi-vigorous. And we looked then at 4 different canopy architectures on these 3 different rootstocks, imagining how our fruiting deconstruction works in each of these training systems. So with a Kim Green bush or KGB, we have very upright fruiting units. With a tall spindle axe or a typical central leader conical shaped tree, we have very horizontal fruiting units. In a super slender axe, it's very high density. The branches are pruned very severely, so we've minimized the number of fruiting spur sites, and we're cropping primarily from the non-spur basal fruit. And these are very close, but still mostly horizontal growth. And then finally, the UFO upright fruiting offshoots with upright fruiting units, much like the KGB. So let's take a look at the tall spindle axe or the conical tree. What we want to think about in examining each of these systems is the light interception and distribution, giving us the carbon gain for fruit size and sugar, and the shade, which is leaves that may have higher respiration rates than photosynthetic rates, and therefore could possibly be a carbon loss. We can think about the summer canopy intercepting light, but we also need to think about the fruiting canopy, where as you see the part that's flowering here before the new leaves have come out and extended. And think about where we're getting optimal light being carbon positive and where we're getting shade being carbon neutral or even negative. And so here we can see that the dark green lines locate where we're getting the most optimal sunlight. in the fruiting part of the canopy. And depending on how well we prune horizontal branches onto this site, we can get light incursions back into the shade of the middle of the tree. So light use efficiency relative to the fruit-bearing wood decreases as the season progresses. And as that structure becomes more complex and irregular and competes with the neighboring trees, any excessive shoot growth that we get wastes our growth resources and has the potential to reduce flower bud number or quality due to shading. We can look at the same sort of analysis with the KGB, the summer canopy, the permanent canopy, and the light incursions into the fruiting sites. Similarly with the super slender axe. And so now we're starting to move into a two-dimensional planar canopy, increasing the amount of light overall relative to the amount of shade that is developed. And then finishing with the UFO, their summer canopy and the fruiting canopy. And here you can see the bulk of the structure is intercepting light with very minimal shade. And this just shows it in reality, the light interception of both the leaves and the fruits in the UFO fruiting wall. That sun exposure to the fruit helps increase the uniformity of ripening, the sweetness of those fruit, and the firmness because it drives more transpiration to the fruit. And that carries more calcium, making the fruit potentially firmer. So this NC140 trial set up with a trial in Michigan and the variety Benton, a trial with Skeena in Summerlin, British Columbia. Terence had 2 trials in New York, there at Geneva and down in the Hudson Valley. And there was a trial with Skeena in Nova Scotia. And Terence's trials had Regina as the variety. So once these trees started to mature, we looked at the efficiency of picking cherries and saw that the UFO was the most efficient. It took 2 minutes to pick 1 pound of cherries in our replicated picking trials. The KGB took about 5% longer, the SSA 10% longer, and the most complex canopy, the TSA, took almost 40% longer to pick a pound of fruit. So right there, we see a huge labor efficiency as we move to planar, narrow canopies. These are the yield data from our trial, year by year. We're starting in 2013. We would have had a crop in 2012, but we lost it due to freeze that year. So in year 4, the highest yielding combination was the SSA on Gisela 3, the most precocious system. However, when we lost the yield, we also lost a number of spurs due to damage to those spurs from bacterial canker. So it took us a couple years to recover some of the spur bearing capacity. And what we see is the next year, in the 5th year, our highest yields were in the TSA on Gisela 3 and the UFO on Gisela 5, both systems that had spurs that then matured and increased the overall production potential. In the 6th year, the highest yield was with the UFO on Gisela 3 and the KGB on Gisela 3. In the 7th year, the highest yield was on the UFO on Gisela 3. In the 8th year, it was the UFO on Gisela 3 and the SSA on Gisela 3. In the 9th year, it was the UFO on Gisela 3. And in the 10th year, it was the TSA followed closely by the UFO, both on Gisela 3. So these are data that are in metric tons per hectare. I'm going to convert it over to yields in tons per acre now. And a caveat I want to show with these TSA data is our TSA yields were disproportionately affected by raccoons eating the fruit. A couple of the years where we had difficulty with our electric fence. Raccoons were able to climb a TSA tree and hang out on those flat branches and eat a lot more fruit. They were unable to scale the KGB or the UFO trees and only did a minor amount of damage on the SSA. So we have to take that caveat into account. But we look at the overall cumulative yield in this 10-year period, and the highest yielding system was UFO on Gisela 3, followed by the KGB on Gisela 3, and then the TSA on Gisela 3. 4th was the UFO on Gisela 5, and then the SSA on Gisela 3. Let's take a look now at Skeena in British Columbia. So a different variety, a self-fertile variety, much more productive than the variety Benton. British Columbia is a much better place to grow cherries than Michigan is. So better environment, more light, can carry higher yields. And they didn't have the freeze that we did. So they have 8 years of data. But you can see their yields are magnitudes larger than ours. But still, the highest yield was the UFO on Gisela 3, followed by the TSA on Gisela 3, then the UFO on Gisela 5, followed by the TSA on Gisela 5, and then the UFO on Gisela 6. So the bottom line is this very planar, highly structured fruiting canopy, we were able to equal or exceed the yields of the other training systems across multiple varieties, multiple locations, and a 10-year period. So some of our research since that time has been to how do we refine and increase the precision in growing in a UFO system. We now use a couple of trellis wires and twine to set our 8-inch increments to make sure that we fully fill our space. One of the nice things about this orientation of fruiting wood is if you have a gap, it's much easier to fill the gap vertically because that's the way the cherry wants to grow than to fill it horizontally. And here we can see that with this UFO, I have a gap here where my arrow is between these two uprights. We were able to take a side branch and bring it over and let it grow vertically and quickly fill that space back in. So here are some UFO cherries in New Zealand in a commercial orchard. Here they are in Washington State in a commercial orchard, and even in a V architecture, still using the vertical growth, but to capture more light in a V canopy, also in Washington State. So as Jim talked about, we can hedge these vertical systems for a greater increase in labor savings. We can utilize things like the Darwin string thinner for thinning blossoms or perhaps fruits. We can utilize high-tech platforms to get the ladders out of the orchard, much safer for our workers. We can even use homemade platforms. And we're moving towards the ability to integrate robots and higher technologies for sensing, things like LiDAR and camera arrays mounted on tractors or on these autonomous vehicles to map and quantify the leaf area, the spur numbers, the flower bud densities, et cetera, that could then help us with things like selective spraying in intelligent zones activated into different regions that need the spray, or even different types of activation of thinning mechanisms, be they little mini string thinners or air knives or spraying thinning chemicals in selective zones. And Matt Whiting is working back in Washington State on precision electrostatic pollination for years when it's not conducive to bee flying or poor pollination conditions. And this works so much better with a planar UFO type training system. And the Europeans are looking at row by row covering to protect not only from rain, but also insect nettings to protect from things like spotted wing Drosophila. And the last thing I'd like to point out is unique among all training systems, the UFO canopy can be adapted across rootstocks. So the fruiting offshoot number per tree can simply be adjusted in proportion to rootstock vigor. The offshoot number per acre does not change. Your fruiting potential does not change, but based on the vigor of the rootstock, we can alter the canopy accordingly. And you're going to see this plays out nicely in where we're going with peach training as well. So around 2010, we began looking at similar type studies with UFO and SSA on peaches. And I just threw in about half a dozen slides to show the peach work here. Here's a UFO peach at our Clarksville station in its early stages of development. And what we found was we can grow a peach as a UFO architecture, but we need to prune it like an SSA because peach is non-spur bearing for most of our varieties, except those spur bearing ones like Tom Beckman just mentioned. And so we would have to grow longer shoots and prune them back very severely, SSA style, to maintain the types of offshoot uprights that work in a UFO. But when we do that kind of pruning, it does simplify our fruit thinning. What our plan is to do is to tell our thinners that we simply want one peach for every little stub, and that simplifies our thinning. It reduces the cost of hand thinning and optimizes our light distribution. We had a grower that liked our UFO training so much that in 2015, he set up his own UFO orchard. He uses summer hedging. He's found that it's improved the uniformity of his picking, 2 to 3 picks instead of 4 to 5, and higher fruit coloration. And you can see the permanent fruiting structure of this UFO peach is only about the width of a peach basket. So in 2017, we began doing our next generation study, looking at that leader number or UFO offshoot number and how that influences vigor. This was all done on standard seedling rootstocks level. So we altered the number of leaders, 1 through 8 per tree, and we altered the tree spacing somewhat proportionally. What we saw was the leader number affecting tree vigor as measured by the trunk cross-sectional area, and using a single leader tree as our 100% comparison. As we increase the number of leaders per tree, the overall vigor of that tree increases. So as the upright number increased, the tree vigor increased from 20% when we had 2 leaders to up to 80% when we had 8 leaders. But that's the vigor of the overall tree. What we are interested in is the vigor of the fruiting wood, because we're moving to very simplified fruiting structures. So here we're looking at the leader cross-sectional area at 5 feet tall. Again, 1 leader trees as our standard at 100%. And as the leader number increases, the vigor of those fruiting leaders decreases. It's diffused by 33% on a 2-leader tree, up to 70% on an 8-leader tree. Basically, some of the same kinds of things you were seeing in Jim Schupp's recent trial. So individual leader vigor relates to the fruitwood vigor, and that's what we're most interested in. Lower vigor gives us less shoot extension, less shade, and calmer growth. So now as we take a look at these dwarfing rootstocks that are just coming into commercial availability, we can say that if you're growing a tree on a standard level or even a very vigorous guardian, you need to have 6 to 8 leaders or offshoots on that rootstock in order to keep the tree relatively calm and optimize the light environment, that balance between leaf area and fruit growth. If you've got a rootstock that's at about 66 to 74% the size of standard, you probably need a training system with 3 to 5 leaders or offshoots. If you're using rootstocks that give you trees about 1/3 to 1/2 the size of standard, you probably want to develop the tree into a 1 to 3 leader training system. And if you've got a very dwarfing rootstock, such as this root pack 40 that's about 25% the standard vigor, you really need to train that tree as a single leader, SSA style. So the conclusions for cherries, and I think they apply to peaches as well, we're looking, I think, in the future at multiple vertical leaders and planar fruiting walls, UFO style, or other terminology that you may wish. But the bottom line is the concepts are all the same. We want to utilize the tree's natural growth habit. We want to utilize vigor diffusion. We want to utilize the natural light harvesting efficiency that the tree has evolved over centuries. We can achieve equal or increased yields with narrower rows. We can achieve more uniform fruit quality and ripening, giving us fruit with better color, sugar, and firmness. These are easier, more uniform crop load management systems because we have simplified the fruiting units. This is the most efficient canopy for hand harvest, up to 40% faster than some standard trees. And it will lead to easier adoption of individual leader scale precision tools in the future because it facilitates canopy imaging and sensing and robotic technologies. It allows intelligent things such as spot spraying for thinning and growth regulation, and even targeted mechanization of thinning tools like Darwin's or hedging, or perhaps even robotic harvesters. So with that, I'd like to acknowledge people that have funded this work over the years: the International Fruit Tree Association, the Michigan Tree Fruit Commission, Michigan State Horticultural Society, Project Green, and the USDA and NEFA. And if we have time, Mike, we're ready to answer questions or wait until the discussion session.
All right, well, thanks so much, Greg. Really great presentation. I think we probably have time for a quick question now, if anybody has one. I don't see anything in the chat box, and if anybody wants to ask a question live, you can raise your hand. In the meantime, I'm gonna have Terence get his presentation loaded up. So with that, we'll move on to our third presenter of the day. We're now going to hear from Dr. Terence Robinson. Terence is an applied fruit crop physiologist at Cornell. His main areas of interest include orchard systems, rootstocks, crop load management, and precision orchard management. Terence, thanks for joining us.
Good morning, everybody. This is a real pleasure to be here today to join my colleagues, Jim Schupp, who I worked closely with when he was in New York, and Greg Lang, who's been a tremendous leader on cherry research over many, many years. I'm going to try to talk about what I see are the opportunities for stone fruit production in New York, but this also applies to other states in the New England area in particular. Now, we're a little bit north of where Jim Schupp produces fruit in Pennsylvania, and it's a very different climate here than him. And so some of what I say applies strictly to where we are, what I call the northern limits of peach production. And so I hope that I may repeat a few things that they have said, but it'll be in the context of what I think will work in this more northern climate. I first want to start with cherry production, and I do think there's tremendous economic opportunities to produce cherries. The challenges that we face are that cherry trees love to die, and so there's often mortality in cherry orchards. Bacterial canker is a very big problem for us, and we some places have resistance to copper that we use to control bacterial canker. But the biggest issue is the fruit cracking due to rain, and often we have inconsistent fruit set. As Greg mentioned, the large trees with relatively low yields, and unfortunately, the varieties we've grown in the past have all been relatively small and relatively soft in firmness. Heidelfingen is the #1 cherry in New York when I came, and it's a soft, miserable cherry. But we grew it because it doesn't crack so much because it's kind of soft. We also have tremendous problems with bird predation and then poor shelf life in terms of trying to market this. But with the introduction of dwarfing cherry rootstocks and that are more precocious, and particularly the introduction of new varieties, has helped create what I think is a great opportunity to produce sweet cherries in the Northeast. There's 6 strategies I want to talk about in more of a global discussion, holistic discussion of how to produce cherries in this climate. And the first strategy is just keeping the trees alive. And we have found that if you plant cherry trees on large, wide berms that are about 1 foot above the natural soil level, 30 centimeters, you can improve tree survival. Now, that's particularly true in parts of New York, New England that have slightly heavier soils. Cherries like lighter soils. And one big difference between Michigan and New York, particularly northern Michigan, is they have lighter soils. And that area is more conducive to keeping cherry trees alive. So for us, with slightly heavier soils, berms have worked well to improve the oxygen level in the root zone and to limit waterlogging of the root system. We've also found that the berms tend to limit winter injury that's often associated with excess water. But if you plant trees on berms, you absolutely have to have irrigation or you get small cherries. The second strategy of keeping cherry trees alive is the issue of controlling bacterial canker. We continue to rely on intensive copper spray programs, 2 sprays in the fall at 20% leaf fall and 80% leaf fall, and 2 sprays in the spring at bud swell. And then a small little caveat here, we wait to prune sweet cherries until between bud swell and bloom. And so we usually spray a copper spray before we start pruning. And then the day we finish pruning, which is hopefully before popcorn stage, we spray again to cover all the pruning cuts with copper. Another really important thing that was developed primarily by a guy in Northern Germany, and we picked it up from him, is to leave very long stubs whenever we cut back a branch for renewal. These 15 to 20 centimeter stubs, maybe even longer, 6 to 8 inches long, prevent bacterial canker infections of the main trunk. If you cut a cherry branch close to the trunk, you often will get bacterial canker started at the cut, and then it rapidly moves into the trunk. The last thing that we do is we try to make most of our major limb renewal cuts right after harvest in the middle of the summer. So harvest for us is the month of July. So near the end of July, early August, we go in and we make 2 or 3 major limb renewal cuts, because at that time, the cuts heal most quickly and the risk of bacterial canker infection is the lowest. The second big issue, and maybe it's the biggest issue of all, is this rain cracking issue in the east. And there are three major things we've discovered that help. The berms that we build to help keep trees alive also help us remove surface water in downpours. We also put a tile drainage down the alley of every single row in sweet cherries, so that as it rains heavily, that surface water goes to the center of the tractor alley. And if the orchard is on any sort of slope, we can move that as surface water off of the orchard before it infiltrates into the soil. Rain cracking comes from both water that lands on the fruit from rain and is absorbed by the skin, but also it's exacerbated by soil water moving up into the tree after intensive rainfalls. The most important thing is the development of rain protection nets and shields. And this has made cherry production possible in a commercial scale for both small orchards and big orchards. We have done several kinds of things. We built our own nets in the beginning, but what I like the most is a system pictured here on the top right and top bottom right, which is a German system called VOEN, Von Cherry Rain Protection Systems. The one we built on our own tended to get blown down every 4 or 5 years under very strong winds, but this system has a way to manage winds that will not blow down. We tend to close the shelters when the first cherries have the first hint of pink. Before that, they don't crack. And then we divert the rainwater to the alleys where we can move it off the orchard because of the slope of the orchard and the drain tiles that we use. The third thing is to try to manage soil moisture to a high soil moisture content through irrigation, so that when there is a rain, there's not a big change in soil moisture. And so we use daily trickle irrigation to try to keep the soil relatively near field capacity once we get to straw color in cherries. This is some data we took over a bunch of years showing rain diversion nets, the original system we built against a spray calcium system that Jim Flory had kind of invented, and then unprotected. And you can see that even with nets, which are the black square boxes, rain cracking varied between 6 and 7% up to 20%, depending on the year. It was never zero, because we still have soil moisture issues that rainwater creates. We were unable with the calcium spray system to have much of an impact on rain cracking. Now, second way to control rain is use high tunnels. And Greg really has been the leader on this, and we've copied a lot of what he's done. Now, we've had very, very good success with these high tunnels with no sides, with either tall spindle type of shaped trees or UFO trees, or with KGB pedestrian trees. Now, for the tall spindle trees, there's 2 rows inside a tunnel bay. We use a 5 foot by in row by 12 foot between row spacing on Gisela 5 or 6. So I'll talk about in a minute. For the KGB trees you see over here, we tend to use 2 rows also because it's a broad spreading bush. And we use similar type spacings. With the UFO, we use 3 rows per bay with closer row spacings. And that gives us an additional benefit of higher tree densities. With the taller trees, we're trying to pick with ladders or platforms, whereas the KGB trees can be picked from the ground. But what is the effect of the tunnel? This is some 4 charts showing the effect of the tunnel over the first 4 cropping years. If we look at the first chart on the left, this is the cumulative yield in tons per hectare. And where we had a tunnel, we had a lot more cumulative yield. It wasn't quite statistically different because these 2 vertical lines they overlap. But when we factored in the percent rain cracking without tunnel over those years, we averaged close to 50% rain cracking. With the tunnel, we averaged around 20%. And so when we converted that 5-year cumulative yield into yield of good fruit, then there was a big significant difference with the tunnel in terms of good yield or yield of good fruit. And when I converted that to crop value using $1 a pound, which is a relatively modest price, we should be getting more than that. But nevertheless, the differences there were somewhere around $40,000 per acre cumulative over the first 4 years, which would basically pay for the tunnel. So the tunnel does make a big difference in terms of the yield and the crop value you can hope to achieve with high density cherries. Now, a third important factor for growing cherries in the East in these humid climates, I believe, is to control tree size and get precocity, and then use renewal pruning. So we've been very, very involved in the Gisela series. 3, 5, 6, and 12 are the 4 that I think have potential. Ada Breeze is also one that's been interesting. Crimp 6, which used to be called Crimps 86, is also very interesting. And Maxima 14, although it's a little vigorous for me, but it still has some potential. I want to show this data showing the relative sizes of 3 Gisela rootstocks, 5, 6, and 12, with 3 varieties, Lappins, Regina, and Hudson. And this is after 8 years. And you see here in the Lappins, Gisela 5 was much smaller than Gisela 6. And with Lappins, there's a substantial difference between Gisela 6 and Gisela 12. And of course, Mazard is always the largest. When we moved to Regina, though, Gisela 5 was even smaller, and there was no difference between Gisela 6 and 12, with Mazard still taller. And Hudson was somewhat similar, with Gisela 5 being the smallest. When we looked at cumulative yield, all 3 Gisela stocks with Lappins had essentially the same yield, and 4 times what we got with Mazard. And this is the reason why these Gisela stocks are so valuable. Now, Regina is an interesting cherry because it's very crunchy and big, but it's a shy cropper. And so in this study, we weren't quite yet using retain, which I'll talk about in a minute, but nevertheless, Gisela 5 tended to produce the highest yield, significantly higher than 6 or 12. Whereas with Hudson, there were no significant differences between the 3 Gisela stocks, but always much better yields than with Mazard. Now, fruit size is often the question, and Greg mentioned that in the early years, people were really negative about some of the Gisela stocks because they felt like they produced smaller fruit size. But in this trial, we were trying to manage crop load through pruning. And when we looked at fruit size with Lappins, which is a self-fertile and can be small, not as small as Sweetheart, but it sometimes oversets, we got the best fruit size with Gisela 12, and then similar fruit size between Mazard 5 and 6. Now you see here, their best fruit size is around 10 grams. So it's not that huge cherry, but it's a reasonable sized cherry when we try to manage crop load. However, when we moved to Regina, which is a much larger cherry inherently, we had this great result here with, essentially better fruit size on the Gisela stocks than we had on Mazard. And when we moved to Hudson, which is grown as a pollinizer for Regina, we had the much better fruit size than on Mazard. So this data illustrates that with proper management, the fruit size issue with the Gisela stocks is not negative. It sometimes is good. I wanted to put up this summary page of what I think about these three stocks at the moment. So Gisela 5 trees, they're generally around 50% the size of seedlings, but they're four times as productive as seedling rootstocks. And I like to think they can be planted anywhere from 600 to 1,100 trees per acre. 4 to 5 feet in row times 10 to 14 feet between rows. However, with this rootstock, irrigation is essential and aggressive crop load management is required. But if you remember my yield data, with a shy cropper like Regina that's vigorous, Gisela 5 had the ability to produce more precocity and higher levels of production than did either 6 or 12. So I really like it for shy cropping varieties like Regina, and then newer ones like Black Pearl, Burgundy Pearl, and Ebony Pearl. Gisela 6 is a slightly bigger rootstock, 70% the size of seedling. It's also 3 to 4 times as productive as seedling. Density is probably a little lower than we do with Gisela 5. It doesn't seem to have large fruit size, maybe slightly smaller in many cases, but I think it has the right vigor for UFO, unless you plant UFOs very close in row. Now, Gisela 12 is one that I really like for self-fertile varieties. It is a bigger stock. It's more 80% the size of Mazard. It's still very productive, 4 times as productive as trees on seedling. And densities generally can't be as high as with Gisela 5. But for self-fertile varieties, and the two that I've had the most experience with are Lappins and Sweetheart, and especially Sweetheart, it's really a difficult variety to get large fruit size. And Gisela 12 tends to give us larger fruit size, probably because we have more leaf area per fruit, and it doesn't overset as badly as it does on Gisela 5. So we've ended up concluding that self-fertile varieties on Gisela 5 is terrible. It's very difficult to manage fruit size. But for shy cropping and vigorous varieties like Regina and Black Pearl, it's great. When we move to self-fertile varieties, then Gisela 12 seems to be just the best combination. Now, in our experience, I categorize orchard systems, and I probably should not spend much time on this after Greg's great explanation. But we have these open center types of trees. Now, the first one I'll mention is quad axis. It's used quite a bit in Washington. They call it steep leader. I don't like that name. I call it quad axis. Relatively low densities, a 10 by 16 or 10 by 18 or 10 by 20. The second system is Spanish bush. And in Spain, it's not planted at such high densities, more like 8 by 16 to 340 trees to the acre, with more permanent upright limbs that you manage the fruiting on them. And then the last system from our friend Kim Green in Australia of a similar thing as a Spanish bush, but with more renewal of those upright shoots as time goes on. Now, we have found that it's difficult for us to get renewals on the KGB system. So our trees end up starting as KGB, but when we cut out leaders, they don't renew, either unless we cut them all off at the same time, which is one of the treatments Greg had us try a few years ago. So our trees end up starting as KGBs and end up looking more like Spanish bushes at the end. Now, the group 2 are more vertical systems. The standard central leader tree, Mr. Vogel in Germany popularized this, 8 by 16. Another German, Mr. Zahn, pushed the density a little closer, and we call that a vertical axis because there's much more renewal of branches. And then lastly is the much higher density tall spindle, which we have worked quite a bit on here, 5 by 12 in tunnels. And then the last vertical system was developed by Stefano Musasaki, the super spindle, which is essentially the same as an apple super spindle. In this case, in our experiment, we planted 2.5 by 11, but a lot of trees per acre. The last system are the angle systems, a standard V system, which is much like a perpendicular V peach system, 6 by 16. A V spindle system where each arm is managed like a spindle tree. The Marchand system, we had that in one of our early trials. It's a little bit like a forerunner of the UFO. You can see it's not, planted at an angle with these upright branches, but without the more precision management that Greg brought to the UFO system. And that's the last more angled system, 5x10 or 871 trees to the acre. Now, one of the fundamental principles about how most fruit crops respond is that there is a positive influence of planting more trees per acre on cumulative yield. This is cherries on 3 rootstocks. The red line is mazard, and you can see that when you plant mazard at low density, yield is low because it takes long to settle down and fill the space. And if you increase density, you get more yield. But because of the precociousness of the Gisela rootstocks, at all densities, they outperform mazard, tremendously, 4 times the yield. And is one of the reasons why we are so bullish on those rootstocks in the east. There is one slight negative, and that is there is a negative influence of increasing tree density on fruit size. Jim saw that in the peaches. We see it in cherries. You see the red line with mazard, there was very little influence of increasing density on fruit size just because there's way too many extra leaves. It just has gazillions of extra leaves for the fruit it produces. But on the Gisela stocks, as you increase tree density, you tend to get slightly smaller fruit size with some of the steepest slope on Gisela 6. Gisela 5, which is the upper line, and Gisela 12 are very similar, but this Gisela 6 is a little bit lower. And one of the reasons why I tend to favor Gisela 5 for chai cropping varieties like Regina and Gisela 12 for the self-fertiles. When we looked at cumulative crop value, though, then you get a positive relationship between tree density and crop value. You want to make money, you plant more trees. Even though cherry tree is not really well suited with the rootstocks to extreme densities, we still get higher yields if we plant higher densities. And the most steep slope was with Gisela 5. It really responds well to the highest density. In this case, was 1,000 trees per hectare. Now, I want to comment briefly on the trial that is common with New York and Michigan and several other places that Greg talked about, because we had the odd different result than Greg in this trial, and it really revolves around Gisela 3. I visited Greg trials and I could not believe how well his Gisela 3 trees grew. For us in New York at the site, they tended to grow poorly and seemed to suffer probably in year 2 or 3 from a winter injury event. And so it makes me very, very hesitant to have people in my area plant Gisela 3. It's very weak. Even in the earlier trial, when we didn't have damage, it just didn't have enough vigor to grow, to fill the space. Greg seems to do well with it in Michigan, and I was just shocked at his trees, but you'll just have to take these different results and weigh them out yourself. But when we looked at trunk cross-sectional area with Gisela 3 over the 4 different training systems, the tall spindle tended to grow the biggest Gisela 3s. The UFO, super spindle, and KGB similar. When we moved to Gisela 5 rootstock, we of course had bigger trees than any Gisela 3 tree, again with the tall spindle growing the biggest trees. The super spindle here was much smaller because we pruned it so severely, it did stay smaller. And the UFO in our case didn't quite seem to have enough vigor to do the job with UFO. And that reflects over in a minute with the yield. And if you look at Gisela 6, it's just a little bit too vigorous for this high density, but still KGB and tall spindle had about the same tree size, UFO a little smaller. And then the super pruned super spindle of Stefano was much smaller. Now, the interesting thing is slightly different results with Regina in New York than Greg had with Benton in Michigan. Benton's more productive. With Regina, we struggle sometimes to get the fruit set until we really started adopting retain. But in this case, with Gisela 3, yields, even with the best system, which was super spindle, were 12 tons. But with Gisela 5 or Gisela 6, particularly Gisela 5 on the tall spindle, we were getting much higher yields, and Gisela tall spindle on Gisela 6, much higher yields. So that we didn't seem to see any great benefit from the super high density of the super spindle of Stefano Musacchi. And that's partly because Regina doesn't set many fruits on what we call basal buds, and that system's pruning depends on basal bud fruit set. Also surprising to us, and in contrast to Greg's, our UFOs did not out-yield the tall spindle ever. Now, this is assuming that the same spacing that we planted, which was 5 by 12. Now, I'm pretty sure, but Greg, you can correct me if I'm wrong, that you calculate the UFO yields based upon a more appropriate spacing of maybe less than 12 feet between rows. But nevertheless, at the actual spacing we used, the tall spindle was the most productive, and the UFO and the super spindle about the same, with lesser from the KGB. When we looked at fruit size, there weren't huge differences in fruit size, except for we got smaller size on Gisela 3, similar size in Gisela 5 and 6. Now, the high yields of the tall spindle gave about a gram difference in fruit size between a UFO and a tall spindle with the Gisela 5 rootstock. But nevertheless, when we calculate economics, this big difference in yield up here would favor the tall spindle in this particular planting arrangement of 5 by 12, which we use under tunnels. Now, the fifth factor that it's important in sweet cherry producing is to manage crop load. And maybe I should hurry instead of spending too much time on this, but you have to prune differently, and you have to have high nitrogen, and irrigation is essential. And then I just want to end with this, Regina and Retain. This made a world of difference, and Retain applied to either 1 or 2 pouches when you see flowers at the stage shown in this picture. 1 flower out of a whole 50 of them open has dramatically improved fruit set and increased yields with this variety. So I put all of our cherry work together with this. We think you can grow high density cherries with greater than 500 trees to the acre, dwarfing rootstocks, particularly Gisela 5 for Regina and other self-fertile or shy croppers like Black Pearl, but Gisela 12 for the self-fertiles like Lappins and Sweetheart and other self-fertiles. We use minimal pruning during the first 4 years, but we have to use bud removal, and I don't have time to explain that, to get consistent branch breaks on a tall spindle tree. To me, the big change has been new varieties: Crunchy, Big, Regina, Black Pearl, if you haven't tried it, fabulous cherry crunch. Burgundy Pearl, also fabulous. What I love about these Pearl series, they also just hold up well post-harvest, and you eat them a week later and they're just crunchy. Rain protection with either nets or tunnels, berms and tiling, copper spray programs, Retain, irrigation, GA, and bird protection is a whole package that allows us to produce excellent sweet cherries in the East. Now I want to switch to just some of our observations on peach. They basically reflect everything that Jim Schupp said. But in our case, we did a number of studies on the bi-axis and perpendicular V, whatever you want to call it, with spacings between 4 to 6 feet in row and 14 to 16 feet between rows. And it works well. However, we never got the same yield and fruit size that we got off of a quad V. And so in this, maybe it's similar to what Jim Schupp showed, we use slightly wider spacings, 8 to 10 feet in row and 16 to 18 feet between rows. We use columnar pruning on the scaffolds with no secondary branches using renewal. All fruiting branches should originate on the main scaffolds, and we renew them back. Now, more recently, we've been fiddling with more central leader type, vertical axe type trees. And I put this one up here just to show that these pictures, not that picture, but it's very common in France. They have a permanent bottom tier of branches, like an apple tree that's a central leader. However, I'm much more interested in this tall spindle Fusetto type from Italy, which we seem to think has a lot of potential, especially when you consider the concepts that Greg was talking about. Very high tree density, 600 to 800, with 4 to 6 feet in row and 12 to 16 feet between rows. No permanent branches, renewal of everything, and a 10-foot tall tree. Now, with that sort of introduction to cherries, we've done a lot of testing of peach rootstocks. This is one trial. We had a ton of them from all over the world, and we've done repeated trials with every rootstock we could get our hands on. But in the end, almost all of those showed nothing was better than Lovell or Bailey, until we came across these controllers, controller 7 and 8 particularly, and possibly crimp 6. So this is a data from one of our trials of trunk cross-sectional area in the blue bars, cumulative yield in the orange bars, and fruit size in the gray bars. So let's first look at tree size. Controller 6, controller 8, controller 7. Now I reversed these because in my trials, for some reason, controller 7 is slightly bigger than controller 8, although not significantly different. So if you look at the blue bars in terms of trunk cross-sectional area, controller 6 smaller, but then 7 and 8 similar, crimp 6 bigger, same as Lovell. Now, when we look at yield, the orange bars, controller 6 has smaller yield, but controller 8 and controller 7, similar yield with a slight edge to controller 7, but they have essentially the same yield as crimp 6 and Lovell, but smaller trees. And when we look at fruit size, which is the gray bar, in this case, controller 6 was similar, or not significantly different than 8 and 7, but the fruit size didn't differ all the way across. And so there was no smaller fruit than Lovell. So this really opens up a window, I think. They're not perfect, but we have had, as Jim said, no tree losses to controller 7 and 8. We have less experience with controller 6, but controller 7 to me looks fabulous. And I think it gives us the opportunity to plant higher density peaches than what we have been doing in the past, and maybe go to more of a true Fusetto tall spindle peach, or plant them closer together in a bi-axis type of training system. Oh, okay. It is pretty well documented in our work that with peach, we can get higher cumulative yield from a V system than a central leader system, at least over the densities that we've looked at. Now, this was not done with controller 7 or 8, but it was done with Lovell. And if we had slightly greater dwarfing out of rootstock, possibly this blue line, which is connecting 2 central leader trees at 2 densities versus the V trees, we might get more similar type of results, and especially if we narrowed up the rows. So I haven't given up on more vertical peach trees. In fact, I'm pretty enthused about them. I'm going to skip this part right here just to go to this one last slide. This is a vertical central leader peach, tall spindle type, 4 feet between trees. And you see the kind of tree it looked like before and the kind of tree it looks like after. Now, this was in a different country, but in our case, we wait to prune peaches until we've seen growth, primarily for the control of canker. We prune pretty much at full bloom. By that time, we can tell where there's a live shoot on this kind of a stub. And so we cut back to the first or last live bud so that we don't end up having stubs that don't regrow. And so it's very easy to tell at bloom where to cut back. Sometimes you have to cut back 10 inches long, but we don't ever want to cut back closer to the trunk than where there is a live bud to grow a replacement shoot. Let me just skip that. And I wanted to end with just a couple of words for Jim Bittner, who sent some questions about plum rootstocks. We've done a number of plum rootstock trials and also a little bit of training system, but traditionally plums are grown on Myrabalan, particularly 29C version in the East, but it is susceptible to brown line or tomato ring spot virus. In the West, they use mostly Marianas, and the most common one is 2624. It's not susceptible to tomato ring spot virus, but nevertheless, both are vigorous. So in a big 1990 trial we showed that Mariana, in this case, the clone 4001 was much better than Myrabalan 29C, and even better than Mariana 2624. Another Mariana clone, GF 8-1, was also similar. And so we've been suggesting for plums, those 2 Mariana's clones as better. We tested a bunch of other dwarf rootstocks like Citation, Damas, Brompton, St. Julian A, and Texas, but they had poor survival and low yields. Now, more recently, we did other trials with newer rootstocks, particularly Cataman and Ishtara. And this data with Empress showed that the highest yields with Catamount, which is a peach almond rootstock, but it works well with Empress plum. And then secondly, this French rootstock Ishtara gave slightly more dwarfing. If you look at the difference in trunk cross-sectional area, 75 versus 54, but almost the same yield, a much higher yield efficiency with Ishtara, and very few suckers with either of these. These two rootstocks came out of our more recent plum work as potential rootstocks for plums in New York. Now, Jim Bittner posed two questions for me. If you have a weak growing plum and you need vigor, what would you suggest? I would suggest Catamount. It tends to survive very well in New York and seems to have the vigor to push a weak variety. But if you have a vigorous variety that you need some dwarfing, then Ishtara seems like a great option. This is another a rootstock trial with Japanese plum, Oblanaya. And in this case, Ishtara was bigger because it's a slightly different sort of vigor category than Empress, but still had the highest yield. In this case, Crimps 1 seemed to work well, had high yields, but excessive suckering. So that's been our worry about Crimps 1. So our recommendations for plum rootstocks are for vigorous, if you want a vigorous rootstock, Mariana 4001, GF8-1. But for your semi-dwarfing and dwarfing rootstocks, Ishtara seems like one of the best options. The second possible good option of Jaspi. It has very high yield efficiency. It survived well in New York, but it produces suckers, whereas Ishtara produces very few suckers. Potential rootstocks like Crimps 1 seems like it has done well with European plums, but we worry about it in other situations. We've seen some damage with apricots. So with that, I'll rapidly end my presentation and turn it back to you, Mike, for the discussion session.
All right, great. Thanks so much, Terence. Are there any immediate questions for Terence before we get into the sort of open Q&A session? And I'll mention as well as people are thinking about their questions, there has been some conversation in the chat box too, particularly revolving around some of the new UFO peach training systems. So definitely check that out if that's something that you are interested in. There's also a question posed about the Gisela series and bud take. So definitely have a look there with Greg's response. So Terence, we do have a question from Gemma. Are you trying the root packs under New York conditions in peaches?
Yes, only two of them, root pack 40 and root pack 24, I believe. And unfortunately, we had tremendous tree mortality with one of those, and I don't remember which one at the moment. The other one has survived and could be a potential more dwarfing case. But the one we had the most hope for, we lost 100% of the trees due to some winter event in 2017 and 2018. So this is part of an NC 140 trial. And as I looked at all the other sites, New York has lost more root pack trees than any place else in the country. But it was a particular winter when the trees were newly planted.
Terence, I think it was root pack 40, which has almond as in the parentage.
Yeah, that's
so
right.
We were kind of concerned that maybe that almond heritage would be a little less cold hardy. And while New York might have had the most mortality with it, a number of other northern locations also had mortality. And root pack 20 came through well, I think, but root pack 40, we're not recommending to our growers at this point either.
So far with the root pack, what was the other one? 40 and what?
20.
20 has had low yields for me. So it hasn't had the yields that I had expected.
We haven't had any yields. We've been frozen out 2 years in a row.
Okay.
All right, great. Thank you both. Why don't we go ahead and get into the sort of open Q&A. And to start us off, we did have someone submit some photos ahead of time. So I'll share my screen and invite Mo Tugas to hop on and show us a little bit of his training systems and let him ask some of his questions as well.
Well, thank you, Mike. This isn't what I had really intended when I sent you the dozen photos. I was looking for Greg and Jim and others to comment on what we've done wrong over the years.
Oh, are you okay with us putting you on the spot then, Mo?
I'm fine with it.
All right.
I have a tough skin. I've worked with Terence and these guys long enough to develop.
All right. Let me just share my screen and we'll show people what you got going on.
Just as you're showing that, I just should say right up front that we're about 120 acres of orchard and parking and buildings. We're 45 minutes from Logan Airport in central Massachusetts. Our market is primarily pick your own, and that makes a big difference when you're talking about how we grow our fruit. And I'd also would say right up front that we don't feel as though we make any money on stone fruit. We feel as though they're a lost leader to keep people coming to the orchard to buy apples, but more importantly, to buy apple cider donuts, which many years is our second or third most important crop. But we struggle with pick your own to really make a profit. The crews that come out to pick our peaches and cherries are out to fill their bellies as much as they can. And so don't ask me what my yields are per acre. We're concerned with dollars per acre. But yes, we do have to deal with explosive diarrhea from our customers once in a while. So if you want to start with that some of these are redundant. So the first slide, I guess, is a picture of a quad V nectarine, I guess it is, that was planted in 2004. We're pretty much doing all of our peach trees on quad V now, but as you can see, we have wood in the top of the tree that I think is getting a bit too large. Jim, you were out here in 2011 and pruned some of these trees at the IFTA meeting in January. And so they're still standing, still doing okay. You want to click ahead a couple of slides. I got a close up that, there we go. You can't zoom in on that, can you?
I can certainly try.
Well, the reason I took this was, there we go, was that one of the real struggles we've had is keeping fruiting wood in the base of the tree, in the bottom of the tree. I suspect that we really lost control of having young wood in the bottom of the tree around the 4th or 5th year, and we're going to get to a slide on that pretty soon. But being very aggressive with keeping 2-year and 3-year-old wood out of the trees, I think is really important. But we still have some pretty decent wood in the bottoms of these trees, and so I'm pretty happy with them. I should also mention right up front that our peach trees are around 12 feet tall, but we also have a blossy platform, and we pick the tops of the peach trees with the blossy, and the bottom 7 or 8, 9 feet of the trees are picked by our customers. All right, I'm gonna go to the next slide. Just a couple, same thing, just our target on these, by the way, is to have about 20 to 25, I'm going to call them fruiting limbs per scaffold. And it worked for our math. The way that has worked out is if we put 2 or 3 peaches on each of those 20 scaffolds, on each of those scaffolds with 4 scaffolds per tree, it works out to about 700 bushel projected yield. We don't ever attain anywhere near that with pick your own, but that's how we're pruning, is to try to get them to 20 branches, fruiting units per scaffold. This is a 4th leaf tree, and this is how we start them. We use bamboo that we press into the ground. You can't really see here, but there's also a wire that bamboo is tied to. We don't tie our peach trees to the wire. We tie them to the bamboo, and that gives us the initial shape of the tree, and it works pretty well. We do have a Darwin. We've had mixed results with our using of the Darwin, to be honest with you. And Andre is the boss here now. I'm just the farm worker. Why did you move over there? Get over here where they can. But he doesn't really like the Darwin a whole lot. We have overthinned with the Darwin. Next slide is, I think, a third leaf.
So Mike, we should have Jim and Greg and me comment on the pictures before you go away from it.
Oh, sure. Yep.
Thank you.
So I want to go back to that picture in the 4-year-old tree. You know, one of the things that Jim said that I want to repeat for emphasis is low light is death to shoots in the bottom of a peach tree. And you mentioned, Mo, that you might have lost some of that fruiting wood in the 4th or 5th year. And that's when it happens. And so to keep light in the bottom of a quad V tree, it requires never allowing any large branch to develop. That's why I like pruning at bloom. You can tell how far back you can cut, how close to the trunk to still get a replacement shoot. But the second thing it requires is summer pruning. You have to keep the openness, the center of the V open to get good shoot development in the lower part of the tree. So generally in the South, or maybe Jim Schupp's area, they do 2 summer prunings. Here with 1 summer pruning, I think we can get away with it. Just looking at that tree in the winter, I can't tell if it was summer pruned or not, but I don't think it was.
Well, it was supposed to have been.
We did do a little bit of summer pruning there. Yep.
Our summer pruning is, we use a hedger for the outsides and the top of the trees. And then our guys go in manually and try to remove any poles on the inside of the tree. And basically any growth that is growing into the center of the tree that's above eye level. So we do end up keeping a little bit more branching in the bottom of the tree. I suspect though, frankly, Terence, that what we need to be doing is thinning out the laterals more aggressively at this point in the 3rd or 4th leaf, so that we get some double renewal shoots coming from those thinning cuts, and that will give us, hopefully in the future, more laterals to choose from at the bottom of the tree.
So that's a concept that Bob Anderson and I talked a lot about, and I'm glad you articulated, because I hadn't remembered to say that. But when you look at one of those scaffolds, if you've got 30 branches on it and they're all like 1-year shoots, you could think, well, they're all possible to keep. But unless you cut back on about half of them, next year you end up with not enough good fruiting branches in the bottom. So you have to maybe cut off for renewal some branches that might be good fruit hangers this year, just to ensure you have enough for next year. And so I like the mathematical approach, calculating how many we need per scaffold. And often you have many, many more than that, and trying to prune down to that number.
Yeah, I agree. I think we've got to remove half of them. And that, in order to maintain young growth in the bottom of the tree, that we really need to be willing. And it's hard, because once these things start swelling and you see all these potential fruit on the trees, and my boss comes around and says, why are you taking so many of those fruiting laterals off? But I know in the long run, it really has to be done.
Yeah, I agree. And I think Terence did a good job of covering the key points here. The only thing I have to add to it is looking at the first couple of quad Vs that you showed. The other caution that I'd throw is that to be careful with 2- and 3-year-old woods, particularly in the top half of the canopy. That's where you can start to create a lot of shade, and that really can be a problem. So I think you have to be particularly jealous to protect the light that's getting down into the bottom of the canopy. Peach is an acrotonic growth habit. It tends to grow at the outer periphery of the canopy anyway, and light certainly contributes to that. And so you just have to do everything you can to keep light in there. All of this said, I think this is an honest shortcoming of these taller quad V type systems, and a taller quad V system is what I'm recommending to my growers right now. But I'll be I'll be quick to admit that it has its faults, and I'm not in love with it, and I'm searching for something better. But at the same time as I'm not in love with tall quad V trees, I am rather in love with 650 bushel per acre of nice sized, well-colored peaches. And I can't do that unless I go to those taller quad V type trees. So in Pennsylvania, we're summer pruning twice. And once in mid to late June, and again 2 or 3 weeks prior to harvest to make sure that we get good red fruit color. And I don't know if you need to do it twice, but summer pruning is another part of this. I want to just, before I quit talking here, I want to make a comment that someone asked about plastic wires. When I was at your place for IFTA, what was that, 2011 or something like that? You had done some experimenting with the black plastic, the 8mm black plastic, and I saw that and I tried that in one of my blocks. Since that time, there's a new product that's come out, and I believe it's called AgLiner, agliner.com. It's a white plastic. It's actually the plastic material that they use for hail netting in Europe. It's a very hard, high tensile white plastic material. It's about 6 millimeters in diameter. It comes in different sizes, but the larger size is about 6 millimeters in diameter. And you can tie peach directly to that without being worried about cankers. And so it's a nice product, and it's made trellising peach a lot better too. And I mean, you have to understand, here in southern Pennsylvania, everything I'm saying to you right now is heresy. Tall peach trees on trellis. What could be more foreign than that? But the fact of the matter is that when I put those peaches on a trellis and I get those scaffolds all in perfect rows, the way that Kevin Day told me I needed to do all those years ago, I get the most consistent blossom thinning with the Darwin. And we use Darwin as a pre-thinner. We don't try to do an entire thinning job with it. Peach is a high value crop, and I'd rather come in and spend 20 hours per acre hand thinning than wring my hands because I took too many with the Darwin. But it helps with the consistency of the thinning response. It also helps with the consistency of the dormant hedging and the summer hedging. So I'm rapidly coming to think that some sort of a regimented trellis system is the way forward, particularly as we dream of ways that we can mechanize and automate stone fruit production.
All right, thank you, Jim. So I know that Greg Lang does have another meeting to get to after this. So if anybody does have cherry questions, certainly, and peach questions for him, definitely please go ahead and feel free to type that into the chat box or ask us directly. I also see someone did ask, has anyone tried shortening some fruiting branches in the spring to 6 to 8 inches?
No.
We will be trying something like that this year. The approach, and I agree with everything that Jim and Terence has said in response to Mo's questions and pictures there on the peach. And Mo, you look like you're either in a boat or you're rocking in a chair. But what I wanted to say is our approach to moving into the peach realm, as you saw, was from a leaf to fruit ratio point of view, and from a light and shade point of view. And so one reason I like the idea, which is still experimental, of the SSA type pruning and doing it in a manner that our goal is 1 peach per stub, is that you severely cut back all the lateral branches every year on that peach. And so you always start out with minimal shade, as opposed to having anything long enough to carry 2 or 3 or 4 peaches. And so I think, but we have yet to prove it, that we'll be able to keep light and fruitfulness and new shoots for renewal much better in the bottoms of our trees. And the other aspect to that, the leaf to fruit ratio, is that one of the hypotheses we're working on is how many leaves are needed for each stage of fruit growth. And once we've simplified the fruiting unit down to a leader or an upright offshoot and one fruit per stub, the idea is to have one replacement shoot growing off to support that fruit. And we can look at, okay, during stage one, how many leaves do we need for that fruit to grow to its optimal level? At stage 3, how many leaves do we need for that fruit to grow to its optimal level? And so we're trying to look at, if we leave 6 leaves per new shoot to support that fruit and hedge at a particular time and let that regrow until the fruit ripens, is that adequate? Or should we leave 12 leaves? And if we come through and do our pre-harvest hedging, what's the number of leaves that we want to do that leave so that that fruit sizes fully at the end? Do we need 12 leaves? Do we need 16 leaves for that fruit to go through its final phase of growth to its optimal level? Anything beyond what it needs causes shade and is irrelevant. And so that's what we're trying to determine from a fruit to leaf ratio, these answers to the questions about summer pruning timing and how much. And that's going to vary with location because of the vigor of trees in Pennsylvania compared to New York, compared to South Carolina or California.
Great, thank you, Greg. I just want to, go ahead.
Quick comment along the lines of following up with what Greg just said. The other thing that you need to bear in mind with regards to light interception and light penetration is that, the light is important for the fruit color and fruit sizing, but it's also very important for the flower bud formation. And there's good evidence to suggest, I think it was Rich Marini studied it and showed that you need to have 40 or 50% full sunlight in the canopy 40 days after bloom in order to have flowers form. So I think it's not only the amount of shade, but it's the timing of the shade as well. You really have to keep peaches open as much as you can for as much of the growing season as you can.
Yep.
I want to mention, looking at that black strapping that's behind you, Greg, and those beech trees, one thing that we have found with the Quad V is they need to be strapped. They need to strap at about 7 feet. Otherwise, the crop load either splits the tree down the quarters or just makes it impossible to drive, for us to drive through the orchard. So we do use plastic strapping, the kind of packaging strapping that you can half inch wide, black plastic strapping that you can get from Uline or places like that to support the trees.
Yeah, that's actually not black strapping behind me. That's for the UFO, they use steel trellis wire. I had advised plastic. And I said, or you could put old drip tape over the wire to create a plastic barrier. And that's what they did.
Yep. Yep.
I'd like to make a comment about shortening fruiting twigs hangers on peach trees. Where I grew up, that was common practice as a pre-thinning option. If you had a 12-inch long shoot, 18-inch long shoot, you knew you'd have 10, 12 peaches and you only could handle 3. So we would often cut them in half to throw half of those peaches on the ground at pruning. And so it's a very standard practice in some places in the world. The problem with us in New York is the winters, where we lose 50% of our peach buds in winter. And so people are hesitant to cut off buds until they know how many of them are alive, or we lose them in the spring frost timing. But it's a very successful way to pre-thin the tree and improve the light into the center of the tree in the early part of the season. So we've taken that tact that I grew up with to try to apply it to Sweetheart Sweet Cherry. Now, from Greg's work, we know that Sweetheart shoots grow out and they just have a tremendous number of spurs that form near the tip of that. And if we can take those off through pruning every year, never let that any shoot develop on Sweetheart to where we get that big ball of spurs out on the end. By tipping them all back, we can keep the flower bud load low enough especially on Gisela 12, that we can get reasonable size sweetheart. So this tipping back has some real potential to managing crop load for both peach and cherry.
Yeah, that's a
Alright,
great
great.
point, Terrence. We once took some data to show that if we cut off the last 15 to 20% of shoots and varieties like Sweetheart and Lapins, where you can get those heavy clusters, after that shoot grew, what you're doing is you're removing the future cluster. And so cutting off 15% or so of the leaf area could cut off 35 to 40% of the future crop load. And that crop load is the part that's going to be of poor quality because it's all clustered together.
All right, great. Thank you, Greg. I'd say we have a couple other questions here, and I do just want to point out we are getting a little over time now, but by all means, I'm able to hang out a bit longer to get everyone's questions answered so that everybody's
I
able
would like,
to.
I would like to ask Greg. You hear me?
Yes.
I would like to ask Greg about the UFO system with a different number of axes. When you get the year after you get the growth of the axe, you need really to get almost every bud to break in order to get as many spurs as you can to have the fruit for the following years. Now, my question is, how do you do that? As you mentioned, this is not a typical way the cherry behaves. Normally it starts on the top. What do you do?
So yeah, so are you talking about how we get the buds to break on the cordons so that we can form the uprights?
On the uprights.
On the uprights, we don't want the buds to break. We want to maintain the spurs on the uprights.
But you need to produce spurs. How do you produce spurs?
No, the spurs form automatically on cherry, where it's a leaf one year, the first year that it forms, the next year it becomes a non-fruiting spur, and the year after that it becomes a fruiting spur. So the spur is there. The problems that we have is when those spurs grow out into laterals on the cherry, we don't want the laterals. We want them to be maintained.
Yeah, I understand, but normally we don't get as many buds to break from the vertical growth that you get.
You and I should probably email and use some pictures to work this out. Our challenge is to get the buds to break when we're forming the uprights off the cordon. And we use promelin. We can use scoring, but scoring causes bacterial canker, creates potential for bacterial canker. So promelin is our best non-destructive way to create buds to break where we need them to break. But on UFO, we only need that across the cordon. We don't want it on the uprights.
Okay, thank you.
And I'm afraid, Mike, I do have to go. I've got a graduate PhD comprehensive exam to get to in a couple of minutes.
All right. Well, thank you so much for joining us today, Greg. We really appreciate it.
It's been great. Take care, everybody.
So Mike, I want to make a final comment that I was going to make and forgot. And that is these high density concepts with cherry and with peach and with plum, I think give growers in the Northeast an option to basically plant these three stone fruits in the same row configurations that they do tall spindle apple. So for example, if you're a farm that like Mo's that wants to do a U-pick and you have your apples all planted at 3 by 11, you can plant UFO cherries, maybe not 3 feet in the row, maybe you plant 5 feet in the row, but still 11 feet between the rows, just like your apple rows. You can plant peach in a UFO type setting and 3 or 4 by 11, or you can plant plums. So it seems like it allows us to basically grow these three stone fruits kind of the way we do apples. And so mixed farms where you're trying to have multiple crops to pick, you could just pick a standard row spacing of 11 feet, plant everything at 11-foot row spacings. That simplifies all the other orchard tasks by these different techniques to manage the canopy. And especially with a couple new rootstocks on peach, I'm pretty excited about it.
All right, great. Thank you, Terrence. Just a reminder to folks, we are recording this. So if you do need to go, the Q&A session will be posted up along with all the rest of the presentations today. But I do invite you to hang around for a few more minutes to get all your questions answered. I do just want to go back to the chat box. We did have a question from Chuck Mead. I think this one was to Mo, but we can open this up to the whole group. Chuck was asking about if people have tried plastic trellis wire or, just what are people doing for trellises for their stone fruits.
Yes, we use plastic wire, I think as Jim mentioned, but recently we've been using just 12.5 gauge high tensile wire, and we save our old drip tape from pumpkins and other places, and we just slip that over over the wire, but we're primarily tying our trees to the bamboo and not to the wire itself. But we do sleeve wires inside of old drip tape.
All right, great. Thank you, Mo. Just going down the list here. Yep, we can hear you.
No.
Or are we not supposed to hear you?
It was good. I was trying to make it high in fiber, so I got these little crunchy things. Yummy, but I made it with many calories. A lot of fiber, but also calories. Yeah.
Sorry, your audio is not coming in particularly well, Magnolia. So just going down the chat box here, Gemma did point out that there's the Catalan vase. She just mentioned it's a shortened version of the quad V system, 2.5 meters high, better light interception, but needs summer pruning, especially on early peach varieties. And Jake also just mentioned in the chat box in Michigan, he summer trims more wood out than at the dormant season. Surgeon also asked about if anyone's looked at spray coverage for disease control on the different training systems. And Greg Lang did mention that the planar canopies like UFO do have better spray coverage than the 3D. We have a question in the chat box from Abbott. Terrence, can you talk more about the tunnels? Do you need netting if you have tunnels to protect the trees?
When we've used tunnels, we have done no netting additionally, and we've had minimal damage, but there have been occasionally dry years where birds seem to not have other places to go to get moisture, and cherries is their favorite. So in that cases, we have to net the end of the tunnel and the sidewall. And we do that with just standard bird netting.
Okay, thank you.
We do have several acres of hay grove tunnels. Initially, we didn't net other than the sidewalls and the ends, but we found that we have a good population of cedar waxwings here. So now we just net the entire high tunnels. It's easier actually to net the entire high tunnel than it is trying to keep the netting properly in place on the sidewalls.
Okay, great. Thank you both. Mario asked, has anyone top worked peaches successfully?
We have not, and for this reason. Peach varieties change quite rapidly, but peach trees don't last very long anyway in the northern climate. So if you get a 10-year-old peach block and you have a different variety you want to grow to, the peach trees often are on their last legs after 15 years, and it just seems better to rip it out and start over again.
Okay, great. Thank you, Terrence. Chuck put in again, we also use bird netting on cherries under the covers. Gemma also asked about the top work peaches. So I don't see anything else in the chat boxes. Are there any other questions that people have lingering that they'd like to bring up before we conclude for the afternoon? Abbott just put in the netting and tunnels keep the cherries warmer too. All right, well, if anyone does have anything else, feel free to unmute yourself. But otherwise, I'm going to go ahead and start wrapping things up, and unless anyone jumps in and interrupts me. Thank you to all our speakers for joining us today. Again, I'll just mention that the recording of this presentation will be made available within the next week. We'll be sending out an email to everyone with those links once we've confirmed that the speakers are able to share those with us. So keep an eye out for an email in the next couple of days with that. And if you have any other follow-up questions, we can definitely get you in touch with all our speakers. So thank you all for joining us. Mo, thank you for sharing your plantings with us. We appreciate it. And have a great afternoon, everyone.
Thanks, you too.
I have a quick question.
All right, we could probably squeeze you in.
Has any trials been done on almonds in the Northeast? I have a curiosity in them and just wondering if the possibility is there.
So I certainly don't have experience with almond. Jim, Terrence, any thoughts on that? Are you still here?
Well, almonds are a warm climate crop, and I don't believe that they would grow well in our climate.
Certainly with that early bloom time.
I had just heard that there were some hardy varieties out there, and I didn't know whether anybody had any experience with them.
I do not.
Thank you, Jim.
All right. Well, with that, I think we're going to close it. Thanks again to all our speakers, and everyone have a great afternoon.